Hi guys, welcome to your favorite channel where we solve one of the coolest maths problems. So today's problem was sent to me by Stuart, and it's a trigonometric problem. We are asked to solve the equation cos 2 of theta plus cos of theta minus sin of theta equal to 0. So I'll just give you a moment for you guys to give it a go before you see how it's solved. So you may pause the video and try to solve it, and then you are going to compare your solution after you've tried it yourself. Thank you. Otherwise, let's get to it. So to solve this problem, first we have to recognize that the function cos 2 theta can be expressed as cos squared theta minus sin squared theta plus cos of theta minus sin of theta equals to 0. Then after this, you have to recognize that this term is actually a difference of two squares, meaning one can write it as cos of theta plus sin of theta, cos of theta minus sin of theta plus cos of theta minus sin of theta equal to 0. Then using our factorization, this term appears to be common. We can pull it out. So if we pull this term out, we get this. Equal to 0. So two factors equal to 0. We know what happens after that. So it implies that cos of theta is equal to sin of theta. And here we have cos of theta plus sin of theta equal to -1. So I have two equations that I have to solve. So the first one is easy to solve. We can divide both sides by cos of theta, where we get that tan of theta is equivalent to 1. Then to solve this one, what we simply do is we square both sides, both the left and the right. When we square here, this will give us cos squared theta plus 2 sin theta cos of theta plus sin square of theta equal to 1. So this one is easy to solve. So let's do some work here. So we see that here we have two terms, cos squared theta plus sin squared theta, which we know that they will add up to 1, so they will cancel this other side. So from here, we then left with sin 2 of theta equal to 0. Then here we know that to solve this equation, we have to take the tan arctan inverse of 1. So it follows that for this equation, theta will be just pi over 4 plus pi of k, where k is just an element of integers. Then for this one, we know that sin of theta is a function which can only be 0 when the argument is a multiple of pi. So it implies 2 of theta must be equal to k pi, where k is just an element of integers. So it follows that theta has to be k over 2 pi, where k is an element of integers. And therefore, this is our solution 1, and therefore this is the other solution. And therefore the solution is done. Thank you for watching. Please subscribe to my channel to continue watching videos where we solve cool problems like this one. Thank you. But before we go, I'm going to pause here the challenge problem 3 that we are going to look at in our next video, so that you may try it out and then wait for the solution up until it's posted. So the next challenge is from Jonathan, and it's saying evaluate the integral 1 over sine theta cos theta d of theta, and it says use the solution for part A to evaluate the integral 1 over sine of theta d theta. So I will leave you guys to look at it and subscribe so that you can be able to see the solution to this problem. Thank you. Goodbye.